Welcome to week 3 of data communications and computer networks. In this particular week, in this video, we're going to be talking about switching and virtual LANs. The things that we're going to be touching on, okay, now here is as far as switching fundamentals, what is involved with that, again, kind of an overview so get you some understanding of switching and where it's used. MAC addressing, we'll talk about MAC addresses and how it's different from IP addresses. VLANs, virtual LANs, we'll be talking about what those are used for and how they're being used, and part of the switching process. 5, access points and trunk ports. That's 6 ports, not points, ports and trunk ports. Basically, what's the difference and when we would want to use one as far as the access port versus a trunk port. And then get a little more deeper into VLAN, virtual LAN trunking, enter virtual LAN routing, and then kind of look at a few practical applications. And as far as your lab is basically the in the assignments area. So you'll have that to be able to do as the next step for the lab. Okay, so that's the kind of the overall, switching, addressing, virtual LAN are the 3 main components that we'll be looking at. Okay, so switching fundamentals, there's basically 3 things on this particular slide I want you to be able to look at. Number 1, look at the components, the network switch, the layer 2 operation, the MAC address table, the frame forwarding, and filtering and learning. So here is basically the definition of those as far as what each does. Here, just want to get more pictorial, looking at if we had a switch. If we had a switch here, and I'm sorry, there we go. If we had a switch here, if we got PC1, PC2, PC3, and PC1 sends a frame to PC3, the switch learns the PC1's MAC address and on the port, and then switch looks up the PC3's MAC address in the table, and then sends the package with that MAC address. Okay, so the switch here is basically doing that functionality for us. So we connect the PCs on the LAN to the switch, and the switch, looking at the MAC address for each device, can determine where the data should route. And so again, so here are the terms, here are the definitions. Here, switches connect devices within the LAN, and it tells you forwards frames based on the MAC address. Okay, they operate at layer 2 of the OSI model. Focus, I want you to understand how switches work, the role they play, and as a key component, and how they forward frames efficiently. So the switch basically is getting information and determining what particular device should the information be sent to. Okay, in real world, in the office, switches, connect computers, printers, IP addresses so they can share files and resources without sending traffic to the internet. So this is basically internal. This is local area network we're talking about, and how once we get into the network, how we get information to the correct device. Okay, so MAC address versus IP address. The first one I want to look at here is down here in the right-hand corner. And basically, MAC address is basically designated who am I. Okay, so it identifies the device's network interface, the local delivery, and all this is occurring in level 2. The IP address is where am I? So, and that kind of got those reversed. IP address, once it determines where the particular device is, it will go to that location and then get the MAC address for the specific device that's at that location. So MAC address is the actual device. IP address is the location of where that device is basically resident right now. So in looking at another way you can look at this is that for an IP address, it's the street address. Okay, so here we got 123 Main Street, Greensboro. And it tells the network where the device is located. MAC address, think of the MAC address as the person who is at that particular address. Okay. So, and another way to look at it that today, I'm basically, I live at this particular location, and at this location is a person named John Smith. Okay. In this particular case, John Smith. Okay. So John Smith is resident at 124 Main Street. Okay. The IP address is the same. The IP address points to the location of the device. Once I get there, the MAC address gives me the ID of that particular device. So that's basically another way we can look at it. Here is kind of the flow. Your laptop wants to send data to a printer. Okay. Here we have the MAC address of the printer. Excuse me, the IP address of the printer. The laptop asks, who has the IP address of 192.168.1.40? Okay. It sends that out on the network. This is done using the address resolution protocol on IP4 networks. Okay. Again, this is, I want you to kind of concentrate on the flow rather than the particular details of it. So I have a laptop, I'm sending something to a printer. I ask for the IP address of that printer, that being the location. Where is it located? Okay. Here it says, okay, the printer responds, this is me, and it sends back the MAC address of the printer. Okay, once the switch has the MAC address, and I have fat fingers, apology. Once the switch has the MAC address, okay, of the, excuse me, I'm going to have to, once the PC has the MAC address of the printer, it takes the information and it sends that information to the printer. So that's basically being defined here. Okay, this is the flow, how the MAC address is used and how the IP address is used. Again, two different addresses. Okay, the MAC address identifies as a device assigned to a network interface card, usually permanent, hard-coded by the manufacturer. The class example of use, think of your cell phone. Okay, your cell phone has a MAC address. Okay? If you go out and buy a new cell phone, the MAC address changes. The IP address for that phone, depending on how it's added to the network, is going to be the same. So I could have the same IP address with different MAC addresses based on the physical device that MAC address is assigned to. Okay. So that's what's being explained here as far as the MAC address versus the IP address. Okay, so in MAC addressing, key thing, the MAC address is called the Media Access Control Address. They're unique hardware addresses assigned to network interfaces. They're used by switches to forward frames. Key terms, MAC address is 48 bits. MAC address structure, here's the structure here. OUI is Organizational Unique Identifier. So looking at the pieces, the first part of the MAC address is the OUI. The second part is the device ID. Okay. I'm going to have to find a way to not be so sensitive on this. Okay. Okay, so here, the MAC address control number, okay, is unique hardware devices on the network. They're used by switches to forward frames. Okay, understand the MAC address, structure types, and their role in the switch communications. So that's what we're concentrating on now. We have the switch. Switch uses the MAC address and the IP address. And here are the basically the pieces that are involved in getting that packet from where it's sent to the specific device. Key takeaways, MAC addresses are 48 bits. Switches use MAC addresses to forward frames. MAC addresses are assigned by the manufacturer. cell phone. I had an old cell phone, I'm getting a new cell phone. That cell phone has its own unique MAC address. Okay. Broadcast and multicast by special MAC addresses. I could say, if I use this MAC address, I want to transmit to this particular information to everybody. Okay. So it's not really looking at a specific MAC address for that device, but it knows that any device that's on the network, if I do a broadcast, it's going to send that to every particular MAC address that's connected. Okay, so length 48 bits. Okay, you get another example. Again, for each printer, each controller, each iPhone, okay, has a unique MAC address so that the switch knows where to send the frames without confusion. Whereas the IP address, we talked about before, has to be unique. So for each device, we have an IP address associated with it. Okay. This is taking it one step further. The IP address is telling us where the device is located. The MAC address is giving us what the device is located at that particular IP address. Okay, virtual LANs. Virtual LANs allow network segmentation by at layer 2. Remember, OSI has 7 layers from 7 down to 1, creating multiple logical networks over the same physical infrastructure. Okay, understand the VLAN concepts, the benefits, and how they work. And looking at the VLAN, the key thing here I want you to understand is it is a logical network that groups its devices regardless of the physical location. So in reality, I could have a device in California, a device in Winston-Salem, a device in Greensboro, a device in New York, 4 different wide area devices, connected. I could say that those 4 items, either they're physically miles apart or hundreds of miles apart, they belong to a virtual LAN. Okay, so that means that when I have the virtual LAN, I'm not looking at the physical location of the device. I'm looking at the logical grouping of the device. So here, when looking at virtual LANs on a single switch, we have a switch. In this particular case, we're showing that there's 3 VLANs going through that switch: VLAN 10, VLAN 20, and VLAN 30. Okay. One representing the sales area, one representing HR, and one's representing IT. This is kind of an example of how you can segment and put things on a virtual LAN by grouping. Okay, and that's the key thing, is by grouping. Okay, it's explained here. The key takeaways: virtual LANs create separate logical networks on the same switch. VLANs improve security, performance, and management. Access ports belong to one VLAN. Truck ports have many VLANs. Okay. Access one, trunk many. Can use that particular switch. Okay, so that's it. The virtual LAN basically is, again, how can we group different devices into units? For security purposes, I might have everybody that's on my HR VLAN has a certain amount of security associated with it. Okay. Same thing for IT. Not everyone in IT, not everyone who's in the business need access to the devices that are connected for IT. So that's the concept we want to get across, that this is virtual and it's based not on the physical location of the device, but the grouping location of the device. Okay, so access ports versus trunk ports. Key thing I want you to concentrate on here is the access ports uses one VLAN. Okay, so when I'm going out from a port in a particular switch, okay, that if I'm using an access port, that is basically connected to one virtual LAN. If I'm using the trunk, and we use the trunk, remember when we were talking about the type of networks. Okay? So we're using a trunk. The trunk says it doesn't matter what the particular VLAN is, because I'm a trunk. I can use multiple VLANs or multiple LANs and basically route it across that same path or that same trunk. Okay. So one is for access ports is for one VLAN. The trunk port is for multiple VLANs. Okay, VLAN trunking. Okay, this is basically looking at the VLANs from a trunk's perspective. Okay, trunking allows multiple VLANs to share a single physical link between network devices using tagging. Okay, so the key terms, the trunk link tagging, the trunk port, allowed VLANs, native VLAN. Those are the definitions described here. Okay, here are some of the examples. Then how is it used is basically listed here. As far as allows multiple VLANs to cross the same physical connection. And this was the case when we talk about the trunk port carries tagged frames of all allowed VLANs. Okay. Yeah, see that is, okay. I'll get that fixed and try to find a way to freeze it so that it's kind of sensitive to the touch. Okay, so the key takeaways with the VLAN trunking, trunk links carries multiple VLANs using H201 tagging. Okay, and the tagging is just basically how do I put tags on various components so that I know that it goes down a given trunk. Okay, so native VLAN is set untagged. Keep native VLAN settings consistent on both ends of the trunk. Okay. Let's see, the quick reference. Here's the 802.12 tag is for 4 bytes. Okay. VLAN ID range is from 1 to 4,000. Native VLAN default for VLAN 1. Okay. So if I don't specify it, I'm going to say this is VLAN 1. And then trunk support carries multiple VLANs, access ports. Okay, real world in a large office, switches on different floors are connected with a trunk link so that the department, sales, whether sales, HR, IT, can communicate without separate physical links for each VLAN. Okay, so we don't have to have a separate port, okay, on a switch in order to transmit things from various LANs, multiple LANs. Here, I did kind of skip over this as far as the 802.IQ tagging. The standard that adds 4 bytes tag to Ethernet frames to identify the VLAN. Okay, so again, this is based on here. I have a VLAN coming in. I put a tag on it, and once I tag it, I can send it across the trunk. Okay. The next one comes from a different VLAN. I take that information, I tag it, I take the information, I send it across the same trunk. But now I know the difference about what I sent because I've tagged that with the 802 1Q. Okay, that's what's basically here as far as what's happening in the tagging. Okay, intervan routing overview. Here, the key thing is intervan routing allows the device in different virtual LANs to communicate by routing traffic between virtual LANs. So I can have 2 virtual LANs that are basically coupled by grouping and not by physical location. And I have the capability to communicate from VLAN 1 to VLAN 2. Okay. Okay, so that's what that's saying. That's an inter-VLAN routing. How do I route such that I'm working with nothing but virtual LANs? Okay. So here's a routing on a stick, a method of inter-VLAN routing using a single router interface, okay, without sub-interfaces. Layer 3 switch, a switch with layer 3 capability that can perform inter-VLAN routing. And remember, we were talking about services layers. Go back and look at the OSI and layer 7, what it does, and layer 6, what it does, layer 2, what it does. Understand what's happening in the various layers, because the references here are basically saying the functionality that we're performing in a given layer, okay? there could be a switch on each layer depending on what you're trying to do. So that's here as far as layer 3 switch. This switch exists at layer 3, okay, in order to perform the functions. SVI, switch virtual interface, a virtual layer at layer 3 associated with VLANs on a layer 3 switch. Okay, so I can have a layer 3 switch, a layer 2 switch, okay, depending on what I'm doing and where I am in the process of OSI. Okay, those are the key things that again, that I can basically communicate a virtual LAN with another virtual LAN. And the key thing here is when I'm going across the trunk, then I can tag it. So I know that when I send something from virtual LAN 1, I can tag it as virtual LAN 1. When I'm sending information from virtual LAN 20, I can tag it as virtual LAN 20. So again, it's trying to give a view of what's going across that trunk and how do we keep track of. Okay, practical applications here, network segmentation. Okay, dividing a network into smaller broadcast domains using VLANs. Okay, I have a big network and I'm breaking those down into sub-networks by virtue of VLAN. Example, sales, HRIT are separate VLANs. Okay, improves security. Okay, reduces broadcast traffic. Okay. Okay. Security isolation, keeping sensitive data, separate VLANs, controlling communication. Performance optimization reduces unnecessary traffic by limiting it only to the VLANs that is needed. If I don't need any information for VLAN 20, okay, then it's practical. Oh, excuse me. If I don't need the connection and traffic from a group of devices, okay, I can take those devices, group them into a VLAN, and now I've separated that from everything else. So whenever I send the new VLAN, I'm only sending that information across the trunk, across the access port. So it's basically cuts down on traffic because of how I segmented the devices on the particular VLAN. Okay, so that's basically it. Real quick, be sure you look at this, look at the high levels. Again, I'm not looking at the details, but I am expecting you for you again to understand the MAC address, understand the IP address, understand virtual LANs, and then understand switches. So switches, virtual LANs, IP address, MAC address. Those are the 3 areas that I'm looking for you to make sure you understand that process. And those are probably where the quiz is going to come from as far as the normal participation quiz to kind of prompt you to be able to look at these particular videos. Okay, so that's it for week 3, and we will see you on Thursday. Have a good one. Bye.